specifically about quadratic equations, so we're talking about these roots here. So if ax squared plus bx plus c is a quadratic equation, so any quadratic, this is the general form, then its roots, alpha and beta, alpha plus beta, with roots, sorry, I'll put it here, with roots alpha and beta, so that's just any two, whatever those numbers are. Then alpha plus beta will equal minus b over a, and alpha times beta will equal c over a. Does that make sense as a given, or do we need to do anything to prove that? Does it make sense? It makes sense? Can you explain why it makes sense? Because it works like that? Gonna need more than that.
I've tried it before.
You've tried it before? It works? Oh, sweet. Okay, so if we get, we could probably do a little proof here. I'm trying to remember how to do it, but I'll try and do it. Ax squared plus bx plus c in general. If it is, no, well, we're just going to do, I'm going to say that if we had the roots alpha and beta, the product of them like this, if you go backwards from solving a quadratic, that's what it's looked like when it's factorized, yeah? So we're like, oh, we have x minus 2, x minus 3, oh, so what's the root? X is equal to 2, x is equal to 3. So working backwards, alpha, beta, I would have to multiply this by a, of course, for the specific one, wouldn't I? Because a bunch of equations will have those roots. For instance, like that one would also have the same roots, and the a would have to determine how wide it is. Does that make sense? So that would have to be multiplied. So these two would have to be equivalent, yeah? So if I multiply this right-hand side out, what do I get? I get x squared minus alpha x minus beta x plus alpha beta, yeah? Multiply the right-hand side. I'll do nothing with the left-hand side just for now. I think this is going to work out for me. Let's combine some terms over here. So I get x squared minus alpha plus beta x. So if I factor out minus 1 out of those two and put them together, does that follow? Yeah. Plus alpha beta. Does that follow? That it would be plus here, yeah? Okay. And then if on the left-hand side I divide everything by a, so I get x squared, factor everything, a out, b over a, x plus c over a, if I factor out a out of this. Yeah? So we can see the equivalence now that b over a is the same as alpha beta, but negative. Because they're the opposite signs. But c over a is the same as alpha beta, whatever alpha beta was. So alpha could have been 2 and 3, and you could have worked the same way through. So this thing here is called the sum of roots, and this is called the product of the roots. So there's a direct relationship between when we see a quadratic equation and how the roots interact, I suppose you could say. This is kind of the proof. You won't need to do that again, but you will need to remember these two. There is, in the formula booklet, which I'll be giving you next week, there is a kind of, this is in the formula booklet. I don't know if it's up here. The problem is it does it for all polynomials, which is a bit less specific. This is specifically for a quadratic. Remember, a polynomial is any function that has x's, like x cubed plus x squared plus x. It's like this family. That's a polynomial. X to the power 7 plus x6 and so on. That's a polynomial. So this is a type of polynomial function. And it's an x squared, and that function is called quadratic. So this only works for quadratics. Right. So how are we going to use it? How will we use it? So, yeah, sure. I think that is just what's there. So let's look at a question. I'll do it over here to the left, so we have this still here. So if we have a quadratic equation. This is our quadratic equation. Plus 5x minus 1 is equal to 0. If we are given a quadratic equation and the roots of the equation are alpha and beta. Okay, they haven't told us the roots yet. Find the quadratic equation with roots. With roots 3 alpha and 3 beta. So I suppose that one way you would be thinking of going down, considering the maths you've done so far, is to kind of ignore this and go straight out. Let's get the roots for this. Let's go with our new formulae to see can we get there quicker, because I think the roots of this is going to be a bit ugly looking. Yeah, they might be irrational and surds and all sorts of things in them. So let's go with our new formulas. So I know that, right, let's get the sum and product of the roots of this equation. So the sum of the roots, I know that alpha plus beta of these two roots are going to be minus b over a. So minus 5 over 4. I know that. And I know that alpha times beta, the product of the roots of this equation, are going to be c, which is minus 1, divided by a, which is 4. So minus 1 over 4. So that's something I know from, without having to find the roots. I know that they add to give this, and they multiply to give that. What happens with, what would 3 alpha and 3 beta look like? Well, the sum of the roots of the 3 alpha and 3 beta equation, the sum of the roots, well, we don't know. But it's the same alpha beta, yeah?
But can you not just find alpha and beta from the first two, or we still keep them?
Yeah, I was kind of thinking the same.
Well, we can, you could find what the roots are. Yeah, you could. But what's the question asked for? Find the quadratic equation with the roots, 3 alpha. So we don't need the original roots. We need the new quadratic equation. We don't really care what these roots are. But notice what I do here. If I factor out that 3, then it's just 3 times this number, isn't it? So it's minus 15 over 4. So I know what the sum of the roots are for the new equation. And the product of the roots is going to be 3 alpha, 3 beta, isn't it? That's going to be 9 alpha betas. So that's going to be minus 9 over 4. We happy with that?
Wait, why do you times 3 twice?
Because this is the product of the roots. So this is one root, this is the other root. I got to multiply them. Yeah. All right. So with this information, can I form the quadratic equation?
Yeah.
Yes.
Yeah.
I think I can. Can anyone call it out to me?
A is 4.
A is definitely 4. So 4x squared. Why is a 4? Because the bottom of both these refers to this a.
D is 15, positive 15.
Yeah, it'd be the opposite sign.
And then C is minus 9.
Yeah, done.
How did you guys get that?
Look at the numbers over there. Like they're both over A, and down there they're both over 4. So A has to
B will be the opposite sign to this.
Oh.
So B was minus 50. Remember, this is B over A, or negative B over A.
Oh.
That is in the new one, that is the sum of the roots, and this is C over A. And what did these A, B, and C refer to? Well, they refer to the general form, ax squared plus bx plus c. So I can just use those numbers and put them back in here, and now I found my new quadratic. Okay, if that one made total sense and was straightforward, maybe try question 9 or 10. If that one was a bit of a, I'm not sure, do maybe question 6 to start off with. Up to you. Do 2 questions from this, and then we can move on to the weekend's homework.
The weekends.
Yeah.